So just to recap, the inscribed angle is the angle with its vertex on the circle, and its two sides are chords. So in this case, ABC is the inscribed angle. The intercepted arc is the arc that lies between the two blanks of the inscribed angle. That would be sides. Someone said sides before. And then the measure of the inscribed angle is equal to how much of the measure of its intercepted arc? What do you think? So think about what I would divide by. So to figure this out, I'm going to help you. If you draw in like the dashed central angle, do you see that central angle from P? So APC. You can actually draw it in if you want to. So APC is the central angle. What type of angle is that? APC is acute. I think it's greater than 90. So that would be what? Obtuse. It looks like it's obtuse. I agree with that. So, but is B also obtuse? No. So ABC looks like it's going to be less than, equal to, or greater than. Which one? Less than, equal to, or greater than the other angle? Less than. It looks smaller. So what's true? Let's recap what last lesson was about. The central angle and the arc that it intercepts. What's that relationship? Are they equal to each other or something else? Come on, party people. What do we think? Go back to your notes if you need to. Central angle and the arc, what's that relationship? Ronaldo's looking it up. You guys also can look it up. Not on your cellular device. I didn't think about it, Stephen. I know what you mean. Okay, the central angle and the arc are equal, okay? So that means AC is greater than 90 because this angle is greater than 90. Okay, is this angle right here greater than 90? No, so it would not be equal to it. It's going to be smaller than it. It is equal to, any guesses? Half, third, 2 times, a fourth. It's a half. It's okay. I wanted to get there. I wanted you guys to get there on your own, but that's okay. We didn't get there. It's okay. Measure of ABC is the angle. It is equal to 1/2 measure of the arc that it intercepts. So it intercepts AC. Questions on that? Okay, let's go ahead and pause there on that note, and we're going to do some examples. So go down to, we're going to ignore intercepting a diameter and overlapping the arcs. We're actually going to figure out that relationship using inscribed angles. I don't have to look at the time. I'll tell you when our time is up. No worries. With your highlighter, highlight the answer, what we're looking for. We're looking for WXY, that angle. So trace it. WXY is the angle. Remind me, is the angle less than or greater than the arc? Less than, yeah. No worries, we're learning it. So the angle is going to be the arc multiplied by 2 or divide by 2? Divide by 2. We're going to get there. It takes some practice. So take that arc and cut it in half to get the angle. What is that? 31. Very good. If you got a calculator, you might need it for later on, but right now, these problems don't need it too bad. Number 2, like we did before, we're going to trace it. So DFG is the arc. So find D, G, D. Oh, yeah, I'm writing it right. DGF. I think I said it wrong. Okay. DGF. That's the arc. That intercepts 113. So what would I do to 113 to get that arc? The arc is equal to how much of the angle? Yes, we got there. Okay, 2 times the angle. Okay, so 113 times 2. What is that? 226. So far, we're rolling. We're cooking. You know, that's not a new saying. I don't think it is. Let me cook is the new saying, but we're cooking. I think that's old. It's from my day, back in the day. Are you good, Gabby? You're cooked? You're burnt? Yeah. PQR is that angle right there. I don't have any of the measurements. I don't have any arc measurements, but does that necessarily mean, like, do we know what that arc that intercepts PR? It's half of the circle, and half of the 360 degrees is 180. Yeah, Rayan got it. So 180 divided by what to get Q, PQR? Yeah, so what's half of 180? 90, yeah. So that means Q is what kind of angle? A right angle. So that is actually the next property of inscribed angles. So intercepting a diameter, if an inscribed angle intercepts the diameter, then it's actually a blank angle. Yeah? Okay. So BAC, that angle right there, draw in your square. How many degrees would BAC be? You got it, 90. Okay, number 4. We're looking for BC, so highlight that part. I'm not given the angle that intercepts that. I'm not giving the correct inscribed angle. Any ideas on how to figure that one out? What would I do with 47? Because, I mean, that's the only thing I have. Yeah, I agree. Times it by 2 to get that arc. That's not going to be my final answer, but it's hopefully going to help me. Because otherwise, I don't know what to do. Calculator might help with this one. Yes, no, maybe? What did we get? 94. Okay. So that's this part. There's a couple ways to do it. There's one easy way, though. Do you know BCA? BCA, that whole arc? 94? You can add 94 to what? Not 47, because they're not the same thing. So you would add arcs together, or you would add angles together. Do I know this whole total? This is 180. What would this be? 180. So if I know the whole from B to A is 180. Yeah, subtract 94 from 180. I think I heard it. 86? Okay. JKL. That's an angle. JKL. Okay, so I need the arc that it intercepts. Can I find that arc? Can I find that arc? It's a big arc. What do you think? And then, yeah, take the 2 that we have and then subtract from 360. We want to find the leftover. So when we're finding the leftover arc, we just take away the 2 that we have. What is that? 108, 118, 118. Okay, and then 242. So what would be the angle? If the arc is 242, how would I get the angle? Half of it. What's half of 242? 121, yeah. So divide it by 2 to get the angle 121. I agree with that. And the last one we got here. RST is what we're looking for. Go ahead and trace that angle RST. What arc does it intercept? This one right here? Okay, that one right there. So we don't have it. Can we figure it out? Yeah, we just did it. Go ahead and find that little remainder. Add up what we have. Subtract it from... Yep, 360. 360. We'll get there. 360 minus, and then add these guys. I ran out of space. I had to write tiny. It's satisfying when that happens, isn't it? Yes. Oh my gosh. That's my favorite thing in the whole wide world to do, is to pop my... It is 82. Audrey's like, come on, it's 82. Let's move on. Okay. Okay, if RT is 82, what is RST? Yes, divided by 2. So 82 divided by 2 is 41. What about RUT? That's another angle. RUT. It's that angle right there. What arc does it intercept? RT. So what would it be? Yes, it's going to be the same thing. Because they intercept the same arc, it's going to be the same number. So both of those are 41. That's the last thing for inscribed angles. And then we can move on to inscribed quadrilaterals. Let's go back up. Are we okay? No. Are you over it already? The face that you just gave me. Okay, if two inscribed angles intercept the same arc, then the angles are what? What's true about them? Congruent. I love it. Yeah. You're just asking. I think it's a great time. I think this is so fun. Yes, go fast. Okay, ABD. ABD is this guy. What else is it equal to? C, A, C, D. Very good. A, C, D. You could also write DCA. Do you want to do an algebra one or do you want to? Okay, that was a hard no. Let's go on to the next stuff. We'll do algebra. We'll come back to it. No? You want to do it now? Pick one. Let's just pick one. I know, I'm sorry. Which one would you like to do? 7? Okay, cool. Beautiful. Can I tell you, I think my other class picked the same one. Okay, solving for x, we have the inscribed angle here. And then we have its arc right here. So what is the relationship between the inscribed angle and the arc? Divide by 2 for the arc. So you can I easily divide 158 by 2? Sure. If you couldn't, you could just times this by 2 and set them equal to each other. Okay. Once Steven gets back. What's 158 divided by 2? 79 is correct. So that's this angle right here. So to solve for x, you just set it equal to 79 and solve. Go ahead and try that. Divide by 2. So it is 11 because you get 8x equals 88 and then dividing by 8. Yeah, very nice. Okay, let's go to the next page. So we're going to ignore the back real quick and we're going to go to inscribed quadrilaterals. If a quadrilateral is inscribed in the circle, then its opposite angles have a relationship. We're actually going to figure out the relationship. So do you want to compare A and C, those two opposite angles, or B and D? A and C? Okay. So for A, pick one of your colors, highlight it like in the middle, just to map it out. And then find the arc that it intercepts. And then write little a. We're going to call that one little a. And then with a different color, you're going to do the same thing for its opposite angle. So C intercepts from D to B. So we're going to write little c there. I should have done it in the same color, like pink, little c. Okay. What do you notice about the arcs, A and C? Not necessarily half the circle. Ronaldo. Not necessarily half of each other. They're not equal to each other, but like when you add them up, what would you get? The whole circle. Yeah, 360. You guys said it. So A plus C actually gets you 360. And now you're saying half. What is half of the arcs? The 180. So if I divided this by 2, if I divided the whole thing by 2, what would that accomplish? That might be a jump that I'm making. So if I divide both by 2, the arc divided by 2 gets you the angle. So if I'm dividing A plus C, the arcs, dividing by 2, that actually gets me what these two are adding up to be. So dividing by 2 actually gets me what the angles are equal to. So angle A plus angle C actually equals 180. It's kind of smushed. There's a line right now. So my answer is no. Okay, so AC, A plus C, those are your arcs. If you divided them by 2, you get what angle A plus angle C is equal to, and 360 divided by 2 gets you 180. So what's the relationship between the opposite angles? They are supplementary. If they add to equal 180, they are supplementary. Okay. Encircle P to the right. We have one that A, measure of angle A, plus measure of angle C equals 180. And then the other opposite angles are B and D. So same equation, measure of angle B plus measure of angle D equals 180. Questions on this? Say that again? Yeah, absolutely. I'll keep it up here. So we're going to go over a couple examples. I would like to go over, I think, 2 and then one of the word problems, or not word problems, algebra problems. Are we okay with that plan? Okay. For number 2, we have Q. So could we find the angle opposite Q? Yeah, what would we do? What's true about the opposite angles? They're supplementary. That means what? They add to equal 180. So if I have one of the angles, what would I do with it? So S, okay, if you want to do it that way, that S plus 93 equals 180. And then what do you do? You are cooked. You are not lying. You know, I've had a long day too. I feel the same way. I'm sorry. That sucks. 180 minus 93 gets you what? 87. So S is 87. Okie dokie. What do we do next? Okay, here, I'll give you a hint because it's kind of tricky. I don't have any of the other angles, and I need to figure them out, but I do have the arc. So I'm going to go ahead and take the 2 arcs that I have, and I'm going to, like, draw it. Do you see? I did a really bad job. Do you see how Q and S form angle R? Yes, maybe somewhat. Okay. So R is the intercepted angle of arc SPQ. So can I find out the whole arc? By doing what? Adding them. Adding them and then divide by 2 to get the angle. So it's 90 plus 126. 126. 216 is the whole thing. So R is the one that's opening up to that arc. We would divide that by 2. Okay, 216 divided by 2. That was genius. Look at you. Now you're no longer cooked, you're cooking. Well, you know, calculators are really handy. They're a great tool for us. What about for P? P is across from 108. So what would I do there? Subtract it from 180.
Oh, okay. And then divide it by 2.
Nope. They're angles.
So, yeah.
It's okay.
It comes back quick.
What's 180 minus 108?
No. Wait, did you have math?
What's
172.
very good. You got
Oh,
72. 72. It's okay. 72. She meant 72. Okay, pick one 4 through 7. Which one did you want to go over?
Let's go over
4, 5, 6, or 7?
Let's do 6. Can we do
6?
both?
Sure, we can do both. Okay, number 5. Number 5. I have two angles. Are they across from each other? Are they opposites? Number 4, I mean. Did you want to go over 5? Okay, so sorry. 5, are they opposites each other? Yeah, they're opposites. So what's the relationship between those two angles? They add to equal 180. Not that they're equal to 180, that they add to equal 180. Okay, 62 and 133. You add to equal 180, yes, if they are inscribed in a quadrilateral. Subtract 195 over, we're going to get negative, which is good because our 5 is negative, our x is negative. Is that 15? Negative 15, so x is positive 3. Okay, cool, that's it. We were just looking for x, we weren't looking for anything else. Okay, and then, did you say 6? Okay, cool. 6, I have L, so we can use N, but I have to find N, I think. Can I find N? Yeah, I can use 91 and 135. If I look at it, it goes from O to M, so I'm going to add 91 and 135. That's what I got. So that's the entire circle. Cut it in half to get the angle. Remember that rule? So N is 113, and then add them to equal what to 15x minus 23, and 113 add to equal 180. We did 226 divided by 2 to get 113. Are you cooked? You know, same. Struggles happen. It's what you do to get over them that matters. Quote by Miss Mark.
I'll use that. I'll tell my kids.
I don't think I can restate it. I think it was a one-time thing. Huh? I literally heard none of that. I'm so sorry. I don't know if I just can't hear you or what. Negative 23 and 113 gets you 90, 80, 90. Which one? Yeah. You guys, you're like, yeah, that sounds right. It's 90. Okay. Yes, I got 90. Can confirm my calculator. Yeah, you can go to the bathroom. Was that what you were asking me? I thought that's what. I didn't. I really didn't hear you. Divide by 15 and we get our answer. X is equal to 6. Is that what we're looking for? Solve for X. We are done. Okay, I'm going to put up on the board